Hi, our lesson now is about differential calculus. First, we'll talk about the derivative of a function. The derivative of a function is the gradient function of the tangent. Let's have a curve, and so you can understand what's the meaning of the first derivative of a function, or the derivative of the function. If we have this curve, and we want to find the gradient of the tangent at this point. First, let's draw a tangent. A tangent is a line that crosses the curve in only one point. So this is the tangent. So the first derivative at point, let's say I have this point A, gives me the gradient of this tangent. So the first derivative gives the gradient of the tangent. Now, if I have a function, f of x is equal to x to the power of n. To find the first derivative of this function, the first derivative is called f prime of x. This is equal to, the first thing I have to do, I need to take the power down and multiply it by a, and then subtract 1 from the power. So the first derivative is n times a times x to the power of n minus 1. The same thing if we have the function written as y is equal to ax to the power of n. The first derivative is dy over dx is equal to n times a times x to the power of n minus 1. So now, let's have a simple example. Find the gradient of the tangent to the curve y is equal to 3x squared minus 5 at x equals 2. So now to find the gradient of the tangent, the first thing we need to find the first derivative. So now dy over dx is equal. We take this power down and I multiply it by the 3. So it becomes equal to 2 times the 3 times x to the power of n2 minus 1. And the minus 5, since it's a constant, always the derivative of the constant is 0, so I cancel it out. So my first derivative is equal to 6x. Now, to find the gradient of the tangent of the curve when x is equal to 2, I have to substitute 2 in the first derivative. So I need to find out the value of dy over dx when x is equal to 2. And this is equal 6 times 2. This would be equal to 12. So 12 is the gradient of the tangent at x equal to. This is the gradient of the tangent. Now let's have a question from the IB question bank. A function f is given by f of x is equal to 4x cubed plus 3 over x squared minus 3. Part A, we need to find the first derivative. The first thing, in order to find the first derivative, we need to rewrite f of x, because in order to derive, I don't need any variable to be in the denominator, so I have to take it up in the numerator. So rewriting it will give me f of x is equal to 4x cubed plus 3x to the power of negative 2, because I've taken it up, minus 3. Now I need to derive. So now f prime of x is equal. I get the 3 down. I multiply the 3 times the 4. So it becomes 3 times 4, 12. And the 3 minus 1, it gives me 2. So 12x squared. Now minus 2 times 3, it gives me minus 6. X to the power of minus 2 minus 1, it gives me minus 3. And the constant, we cancel it out because the derivative of the constant is always equal to 0. Now, part B of the question, we need to find the point on the graph at which the gradient of the tangent is equal to 6. Since the gradient of the tangent is equal to 6, this means that f prime of x is equal to 6. So part B of the question, I need to substitute 6 instead of f prime of x. So I have 6 is equal to 12x squared minus 6 times x to the power of negative 3. In order to find x, we use our graphical display calculator now. So we go to equation and we choose f3, and let's just delete this equation. Okay, we have 6 is equal to 12x squared minus 6 times x to the power of negative 3. And execute again. This gives me x to be equal to 1.